All right, this video is going to talk a little bit about factoring, and we're going to talk about factoring a trinomial. And the first thing we want to remember about factoring a trinomial is, where does the trinomial come from? Factoring, when we talk about it, well, a factor is really just something that's multiplied. Two factors multiply to make a product. But when we talk about factoring as a verb, it's saying, can we find the two quantities? Can we find the two things that would multiply to give us a given product? So if we want to end up in standard form here, this trinomial like we have on the right, x squared plus 2x minus 15, well, we need to try to do our find these two factors, right? X minus 3 and x plus 5. Now we're used to FOIL, and really thinking about FOIL and taking x times x to get you the x squared, and negative 3 times 5 getting us our negative 15, and the combination of that sort of inside and outside, right, to give us that 2x, that's how we're going to sort of come up with our factors. Now, there's two good ways to do that. There's the box method, which is not a bad method, and we'll show you very quickly how that works maybe toward the end of the video. But really, the easier way to go is just thinking about unfoiling these things. So let's think about factoring in terms of FOIL. In FOIL, where do the pieces of this trinomial come from, right? X squared plus 6x plus 5, okay? Well, one thing we want to remember, right, is when we think about this, we can think about algebra tiles if we want to here. Again, if we had an x plus 5 and an x plus 1, I know we don't necessarily already know those things, but think about how those two things would multiply together. X times x, right, makes this nice x squared right here, okay? Then we've got 5 individual numbers, right? These ones over here, okay, that are all getting multiplied by that x as well, right? And that's giving us those 5 red x's right here in that first row. We also have this 1x down here, right? That's also going to get multiplied by an x, right, up top. So again, that's where we get that single x right down below here. And altogether, we have 6 total x's. So we have this sort of combination, right, of these two things. And then finally, we have those 5 ones and that 1 1. We get those 5 green ones down at the bottom there, right? Our goal when we're factoring is to think backwards. It's to think, well, hey, I know all of these things. I've got these x squared, I've got these 6 x's, and I've got these 5 ones. Where did they come from? Right? What do I put in those boxes up at top and all around? How do I figure that out? And again, the major thing to remember is we multiplied directly to x squared. We multiplied directly to these 5 green ones, but we added, right, all of those red boxes together. So when we think about it, right, we multiplied to 5, but we needed those same two numbers, right, 1 and 5, to add together to give us that 6. And in order to do that, right, again, the 6x came from adding the terms from the inside and the outside, came from adding the 5x and the 1, right? But the x squared and the 5, again, came from first and last. They came from just those direct multiples. So in order to go backwards, what we want to think about is what is going to add to the middle, right? What's going to add together to give me that 10, but at the same time multiply to give me that ending number, that 16 in this first example. Now realize that the multiples list is much shorter, right? We've talked about monomial multiplying or monomial factoring. There's a short list of things that multiply well to 16. So let's start with that. I know that 1 times 16 obviously would give me 16. So would the numbers 2 times 8. Now 3 does not go into 16, but 4 does, right? 4 times itself. And really, if you kept on going, now that we've sort of got our list to where it's sort of that halfway point, 5 or 6 or 7, they're not going to go into 16, but 8 does, but I already have it listed. 8 is already in the second pair there, right? So my numbers, in order to get bigger than 4, are going to have to pair up with something smaller than 4, right? Because I already sort of got this part going. This is my short list of factors of 16. Now all I want to think about is, again, what not only multiplied to 16, but what's going to add to 10. And it's never a bad idea just to write that down. Multiplies to 16, adds to 10. Well, of those 3 pairs, 2 plus 8 would give me 10. So what I need to do now is I can go ahead and write my factors out here. I know that x squared came from multiplying x times x. And I know that 2 times 8 is going to give me 16. But I also know that as long as I keep those positive, 2 times 8 is a positive 16, and x times 8 and x times 2, 2x plus 8x, right? 2x plus 8x would have given me my 10x. So my answer then, my two factors, are x plus 2 and x plus 8. I want the two binomials multiplied that would give me that trinomial. Let's try that same idea when we move over here to the right. X squared minus 5x plus 4. Again, I want to know what's going to multiply. Oops, I'm sorry, I erased my box there. We want that over there. What's going to multiply, right, very nicely to give me 4. But what's going to add to give me negative 5? Well, the only things that are going to multiply to 4 are 1 and 4, 2 and 2. But now I want to add to a negative number. Now, in order to multiply to a positive, right, I either need two positive numbers or two negative numbers. So the only way we're going to add to a negative 5 is if I make all of my numbers negative. Doesn't that make sense? We're going to add to a negative, but at the same time, a negative times negative makes positive when we multiply to 4. Well, in that case, negative 1 plus negative 4 is going to add to that negative 5 in the middle. So let's call this x minus 1 and x minus 4. Again, if you FOIL those back out, we're going to get x squared in the front. We'll have positive 4 for this last term. And again, we would have negative 1x and negative 4x, right? Adding to negative 5x in the middle. If you want to, feel free to pause the video now. Try the next example on your own. And I'll work out the answer in just a second. All right, taking a look at it. Again, we want to multiply to negative 18, which immediately tells me, how do you multiply to a negative number? Well, we need one negative and we need one positive, right? So let's take a look at what we can do to figure out this answer. Well, multiplying to negative 18, I know that 18, first of all, needs to be 1 and 18. It could be 2 and 9. We could be 3 and 6. 4 does not go into 18, neither does 5. But again, we've already got our 6. So again, there's our short list of 3 possibilities. I know I want one of them to be a negative number, one of them to be a positive number. And I also know that I want them to add to negative 7. Well, if we're going to add two numbers and they're going to end up negative, if one of them is negative and the other's not, it must be the larger number that's negative. Because a negative 18 plus 1 would still be negative 17, right? It would stay negative. Negative 9 plus 2 is going to be negative 7. Negative 6 plus 3 is going to end up being negative 3. We would keep that negative just like we want. And just like we said in the middle there, 2 plus negative 9 not only adds to negative 7, but it multiplies to negative 18. So my answer again, x plus 2 and x minus 9. Using those same ideas, we can jump over here to the right. Again, we know that 8 is going to have factors, right? We're going to multiply and we're going to add here. Factors of 1 and 8 multiply to 8. 2 and 4 multiply to 8. But really, that's all there is. 3 doesn't multiply into 8, and we've already got our 4, right? Well, how would we multiply to a positive? They either need to both be positive or both be negative. And if we want to add to a negative number, right, in the middle, then they must both be negative numbers. You want to multiply to a positive, but add to a negative, you got to have two negative numbers, just like we did right in the example right above it. However, the problem there is, if I add negative 1 to negative 8, I would get negative 9. And if I add negative 2 to negative 4, that's negative 6. Neither of my two possibilities is going to be that negative 2. So in that case, we just say not factorable or not possible. Not every trinomial can be factored into two binomials. So just keep that in mind as you're working out your problems. Now, one other way to do this, as I mentioned at the beginning, is what's called the box method. Now, with a leading coefficient of only 1, right, the box method actually becomes a little bit cumbersome. It's a little bit of work. Because in order to start the box method, what it is basically undoing what we used to call the table method of distributing. Right? So if you wanted to figure out what was in the box, you would take what was multiplied up here, right? And we would multiply here, and we would multiply over here, and we would fill that box, right? Well, we can use that idea to help us sort of go backwards. But we need to know what to put in the box first. And remember that in this upper corner of the box is an x squared, because again, that's what the first was always multiplied, right? When we look at our factors down below, in order to get x squared, we always said x and x, right? Because again, that's what would go here and here. The 2, again, is always what our constants are multiplied, right? Those two numbers that we need to look for multiplied. And inside the box, right, now here's the tricky part. We need to know what to put in those other two corners. And they're going to be what adds to 3. So in order to fill the box, we already need to think what multiplies to 2 that also adds to 3. Well, the only thing that's going to multiply to 2 is 1 and 2. So I can put a 1x and a 2x here. Now the idea is, now I'm going to look at my rows and say, well, what do these two numbers have in common? And I'm going to put that out here. What does the second set, or the second row, have in common? Well, there's a 2 in both parts, so I'm going to put that out here. Once I've got the rows done, right, I've got my 2 out there. Now I'm going to go with the columns. I'm going to say, well, what do these two columns have in common? Right? Oops, and I forgot my x inside of there. They had an x in common, right? So we put that up here. And what did the second two have in common? Well, really nothing. There's a 1, though. 1 divides into 2, and 1 divides into 1x, so we can put a 1 up there. And it turns out my answers would be x plus 1 and x plus 2. Now, it's a little bit cumbersome because I already knew the 1 and the 2 when I found my two numbers here. So like I said, when there's a 1 in front of that x squared, it kind of gives most of the answer away. So the box method is not bad, but again, it's a little bit of extra work. Again, if we think about it, in order to put numbers in the box, right, I'm going to put the x squared in the upper left corner, and I'm going to put that 54 in the lower right corner. But in order to get the other two numbers, I already need to think, what's going to multiply to 54 that adds to 29? Well, 54 could be 1 and 54. We could be 2 and 27. And really, I just found my answer there, because don't those add to 29? So what I'm going to do is put a 2x and a 27x in the box. Looking at the first row, there's an x in common. In the second row, there's a 2 in common. So I already know that I've got an x plus 2 as one of my factors. In the first column, I've got an x in common. And in the second column, we have a 27 in common, which makes sense. 2 times 27 was our 54, right? So it turns out there are two factors. Now again, the box method doesn't seem like it's probably a lot of extra help this time, because once we found our two numbers, we could have jumped directly to our answer. But keep in mind, it will help us much later on in a later section when the leading coefficient is no longer a 1. That's going to be a great method. If you have any questions about factoring a trinomial into two binomials, make sure you talk to your teacher. Otherwise, have a great day.